Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. As we discussed in introduction lecture that course contents up to lecture number 10 are covered already before start online classes. After session 1, the first important topic is relations. We will cover this topic in 2 lectures in this week, inshallah. Today lecture is first lectures on relations. In this lecture we will cover overview of relation on sets, property of relations. Before we discuss relations, I will give you overview of orders and tuples and Cartesian product. So our cover topic of today lectures are orders and tuples, Cartesian products, relations on set, property of relations. The order of n elements in a collection is often important because sets are unordered. A different structure is required to represent order collections. This is provided by orders and tuples. So we start from orders and tuples. Definitions is described as the ordered n tuples a1, a2 to an is an ordered collection that has a1 as its first element, a2 as second element, an is as its nth elements. Two orders and tuples are equal if and only if each corresponding pair of their elements is equal. In other words, a1, a2 to an is equal to b1, b2 to bn if and only if ai equal to bi for i1 to n. In particular order, two tuples are called order pairs. The order pairs a, b and c, d are equal if and only if a equal to c and b equal to d. Many of these structures are based on the notation of Cartesian product sets. We first define the Cartesian product two sets. Cartesian product of more than two sets also possible. The Cartesian product of the set A, B, A1, A2 up to n denoted by A cross 1 cross a2 and so on again is the set of order pair tuples a1, a2 and up to an, where ai belong to capital AI for I is equal to 1, 2 and to n. In other words, a1 cross a2 cross and so on a cross an is equal to n order n tuple a1, a2 and up to n10, where ai is belong to set ai for I is equal to 1 to n. For example, what is the current product a cross b, where set a is equal to 0 1 and b is equal to 1 2 and c is equal to 0 1 3. So when the current product a cross b consists of the all order pairs tuples a, b, c, where a belong to a capital set a and b belong to set b and c belong to set, and the Cartesian product of a cross b and cross c is described as given in the screen. Dear students, we have three sets like A, B and C, and we want to Cartesian product of 3 in two different ways. If we first take the Cartesian product A and B and then take this product with the set C is not equal to if we take Cartesian product 3 simultaneously A cross B cross C. We use the notations capital A power 2 to denote A cross B, the Cartesian product of set A with itself. The similar A power 3 is A cross A cross A cross, and similar A power 4 is Cartesian product of 4A sets, and so on. More generally, A n equal to pair ordered n tuples a1, a2, and n2. At that ai belong to a1 for I1, 2, 3 to n set. Just suppose set A is equal to 1 to 2, it follows that A square will be pair with 1 1, 1 2, 2 1 and 2 and A3 A square A cube will be pair with 1 1, 1 1, 1 1, 2 and 1 2 1 and so on. Last pair of this will be 2 2 and 2 tuples. Now our main topic start on relations. As no relation is between two elements, that elements may be belong to different sets or same sets. An overview of the relation is the relationship between element of sets are representing using the structure called a relation, which is just a subset of the Cartesian product of the sets. Relation can be used to solve the problems such as determining which pair of the cities are linked by air flights in networks, producing a useful way to store information in computer database. The most direct way to express a relationship between elements of two sets is to use order pairs. Orders n tuple made of the two related elements. Set of the order pairs also called binary relations. Definition of binary relations: let set A and set B. A binary relation from set A to B is subset of causal product of A cross B. Thus, a subset R of the causal product A cross B is called a binary relation from the set A to set B. The binary relation from set A to set B are of order pair where the first element of each order pair comes from the set A and the second element comes from set B. For examples, R is equal to order pairs A0, A1, A3, B1, B2, C3, C0 is a binary relationship from sets A, B, C to set 0, 1, 2, 3. The relations between is A B is denoted by A relation B to denote A B belong to R, and A not relation to B is denoted by A pair A B not belong to R. The graphical representation of relations: let set A is equal to 0, 1, 2 and set B is equal to AB. Then the relations 0 A, 0B, 1A, 2B is the relation from A to B. The relation can be represented graphically using arrow to represent order pairs. First we draw points of the set A and then points of the set B. Then we connect the point set A to corresponding set B if in the relations that pair exist. Another way to represent this relation is used in tabular form. In tabular form, we first a vertical we set A and horizontal we set B elements, and then we cross signal is used to corresponding element of A to corresponding element of P as shown in this relation on set. Definite a relation on set A is a relations from A to A. It is a important concept. Example, let's set A be the set 1, 2, 3, 4, which ordered pairs are in the relations where A, B pairs A divided by B. In this relation, we set that pair in which A divided by A divides B. Relation A divides B, and this solution is shown in figures. The R is the obtained R relation is 1 1 1 2 1 3 1 4 2 2 2 4 3 3 and 4 4. It means that the relation B is divides by A. The graphical representation is also given in these figures. Let we consider other examples. Set A be set 1 2 3 4, which order pairs are in relation R A B so that A is not equal to B. In this case, we obtain relations such that A1 A2 A3 A4 2 1 2 3 2 4 3 1 3 2 3 4 4 1 4 2 and 4 3. The tabular representation is given here. And other examples that we consider, the set A 0 2 3, and we get the relation set that A and B if A is equal to B or A is less than B, and this we get the following relations are 0 0 0 1 0 2 0 3 1 1 1 2 1 3 2 2 2 3 and 3 3. Dear student, on example page slide number 16 are left for you to solve. In this example, consider relations on set of integers R1, R2, R3, R4, R5 and R6. Each relation has conditions, so you are given a task to identify so that the following pairs are belong to which relations. So every student should solve it itself so that they can easily learn the relation on sets. The student, next we discuss the theorem in which the number of binary relation on a set where set A have n element is given by 2 to power n power 2. If A number of element set are n, then the cardinality of the Cartesian product A cross B will be n square. R is a binary relation of A if R belongs a subset of A cross B, that is R is a subset of the A cross B. The number of subset of with k element will be 2 to power k. The number of subset element of A cross B is 2 to power A cross A, so that the total number of elements of a set that have the n element will be 2 to power n to power 2. On base of this theorem, we will consider some examples at how many relations are on a set that have n element. The solution relation on set is subset of the class A class, because A class has an n2 element when A has an n element, and the set with m elements has 2m subset, and therefore there are the 2m square n subset of the element. Thus there are m 2 to power n to power 2 relation on a set with the element. For example, there are a set contain 3 elements. There will be total number of relations in set that contain 3 elements will be 512. And other example is, let's set A consists of the 2 elements. What is the A cross A elements will be relation will be 4. List of the possible relation subset of the A will be also 2 to power 4, that are 16 elements. There's other representation of relations is matrices. A relation between finite set can be represented using 0-1 matrix. And 0-1 matrix is a matrix in which all element entry of matrix are 0 or 1 is called 0 matrix. On this 0-1 matrix, Boolean arithmetic with 0-1 are implied. The suppose R is relations from set A, A1, A2 to Mn to relations set B, B1, B2 to Bn. The relations R can be represented by the matrix Mr is equal to Mij, where Mij is equal to 1 if Ai or Bj belong to R, and Mij value will be 0 if Ai, Bi not belong to R. In other words, 0-1 matrix represents R has a 1 as its value Ij entry when Ai is related to Bj and 0 in this position if Ai is not related to B. Let we consider example to explain the matrix representation of relations. Suppose that set A is equal to 1, 2, 3 and set B is equal to 1, 2 elements. Let R be the relation from A to B containing AB if A is belong to A and B belong to set B and B A is greater than P. What is the matrix representation of R if A is equal to 1 and A2 is equal to 2 and A3 is equal to 3 and B1 is equal to 1 and B2 is equal to 2. Solutions: R is 2, 1, 3, 1 and 3, 2 pair. The matrix for this is MR 0, 0, 1, 0 and 1, 1. The ones in MR show that the pairs 2, 1, 3, 1 and 3, 2 belong to R. The zeros show that no other pairs belong to R. Let we consider another example in which matrix is given. From that matrix we will get the relations. Let A is equal to A1, A2, A3 and B is equal to B1, B2, B3, B4 and B5. And A has 3 elements and B has 5 elements. Which order pairs are in the relations are represented by matrix? Dear students, one point that I missing from previous, the elements of A, set A are represented as a row and the element of set B are represented as a column in matrix. The solution of above matrix is given here, in which for 0 positions in matrix we not consider a pair element, and for the position 1 we consider the relations. The R I1 A2 and A2 B1 and B2 B3 A2 B4 A3 B1 A3 B3 and A3 and 5 is the relation that is obtained from the above matrix. The matrix of relation on set, which is a square matrix, can be used to determine whether relation has certain property. All these matrix representations I discussed above is most related to understand the property of relation. So I have go to the discuss in detail the property of relation. On the base of our given matrix properties, you will understand in better way to decide the which matrix is belong to which property. The most important properties of the relations are reflexive relations, irreflexive relation, symmetric relation, antisymmetric relation and transitive relations. Reflexive relation definition: a relation R on set A is called reflexive if pair A and A belong to R for every element A belong to A. The relation R on the set A is reflexive if for R elements A, pair A and A belong to R, where the universe of the discover is the set of R element in A. For example, that relation R is AB, A divides B on relations on sets A 1, 2, 3, 4. Is R is the relations obtained from above example. Let we first draw the relations, that is R is equal to pairs 1 1, pair 1 2, pair 1 3, pair 1 4, pair 2 2, pair 2 4, pair 3 3, pair 4 4. Yes, 1 1, 2 2, 4 4 and R belong to relation R. So this relations is reflexive relations. Let relations R divided be reflexive, and when we draw this reflexive relation in the matrix form, then we get the following matrix based on this reflection. But the relation R is reflective if and only if matrix R has 1 in every position of its main diagonals. If a matrix have a diagonals once, then that matrix relations is called a reflexive relation. This is the main property of for the reflexive relations. We can easily identify by drawing matrix of the relation, can obtain that if a relation is reflexive or not. If every diagonals on a matrix is 1, then it is reflexive relations. Their source on irreflexive relations is opposite of reflexive relations. Definition: relations R on set A is called irreflexive if A and A pairs not belong to R for every elements A belong to A. Let example: relation R is AB pair A divides not equal to B on set A 1 2 3 4. It is a irreflexive relation. Let we get relations in which relation become 1 2 1 3 1 4 2 1 2 3 2 4 3 1 3 2 3 4 4 1 4 2 and 4 3 pairs. Yes, because 1 1 pairs, 2 2 pairs and 3 3 pairs are belong to R, but not belong to R as well. 4 4 pairs. For every pair should be belong to, not belong to relations R. In these, no pair is belong a relation in R contain 1 1 2 2 and 3 3 and 4, and not these pairs are belong to less. So this relation obtained from the conditions is irreflexive relations. On this reflexive relation, we can also property of irreflexive is also determine matrix representation of relations. The matrix representation of relations is given below, in which we can show that reflexive relations are irreflexive if and only if the matrix has 0 in every position on its main diagonals. It means that if a matrix have diagonal value 0, all diagonal values 0, then that matrix that based on the relations, and in that case relation is irreflexive relations on sets. Third important property of relation is symmetric relation. Definition: the relations R on a set is called symmetric if A relation B or A belong to R whenever relations A, B belong to R. For all A, B belong to A. Universal quantifier. Using universal quantifier, the relation R on set A is called symmetric if for all A, B belong to A. A, B relation belong to R imply that B, A relations also belong to R. The relation R on set A is symmetric if for all A, for all B, AB pair belong to R imply that BA pair also belong to R. In that relation will be called symmetric. Let we consider example symmetric relationship. Let relation R AB जबकि A divides B on A set 1 2 3 4 is R is symmetric. First we get relation on above conditions, that is 1 1 1 2 1 3 1 4 2 2 2 4 3 3 and 4 4 relations. From this relation we get then 1 2 pairs belong to relation R, but 2 1 pair is not belong to R. So this relation is not symmetric. For symmetric relation, it must be contain 1 2 relation as well as 2 1 relation also. Then that case this relation will be symmetric, and otherwise it is a not symmetric. Let we consider another example. The relation R AB and A is not equal to B on set 1 2 3 4 is R is symmetric. First we get the relations 1 2 1 3 1 4 2 1 2 3 2 4 3 1 3 2 3 4 4 1 4 2 and 4 3. Let we consider first pair is 1 2. First element is 1 and second element is 2. In A is 1 and B is 2, and we get pairs such that A value is 2 and B value is 1 in this pairs. And other first pairs, second pair 1 3, we also get 3 1 position, and third pair is 1 4 and also we would get 4 1 in this relations. And 2 1 relations in opposite also found 1 2 relation, and 2 3 relations we get also 3 to 1 relation, and 4 2 4 relation also with 4 2 relations in this pair in this relation. So 3 1 already we get, and 3 2 we also already get, and 4 3 relations pairs in this relation also contain 3 4 and 4 3 relation, and 4 1 relations and 1 4 relation consist, and 2 4 relation pairs and 2 4 relation also present. Yes, this relation is symmetric because every A1 A B pair belong to R imply that B A pair also belong to R. The matrix representation of this pair is given below. A relation is symmetric if and only if Mij is equal to Ji for all its Ij values. So user can easily identify that matrix using matrix notation that this relation is symmetric. The symmetric relations also an other property from which we can identify that this relation is symmetric using matrix notations in terms of matrix. R is symmetric if and only if Mij is equal to 1 whenever Mij is equal to 1. This also means that Mji is equal to whenever Mij is equal to 0. Consequently, R is symmetric if and only if Mij ij is equal to mji for all pairs of the integers I and j with I is equal to 1 to n and j is equal to 1 to n. R is symmetric if and only if matrix R is equal to transpose of the matrix R. That if we transpose of the matrix, if both matrices are equal, then the relation of on that matrix is built is a symmetric relations. If matrices are symmetric, then relation will be also symmetric. So if we take the transport of the relations and that we get the similar matrix, then in that case two matrices are similar. A relation that obtain a such similar matrix is called symmetric relations. Another property of antisymmetric relations. It's clear that the term symmetric and antisymmetric are not opposite, because a relation can have both of these property or may lack both of these property. A relation cannot be both symmetric and antisymmetric if it is contain some pair of the form A, B, where A is not equal to P. Now we consider definitions. Relations are on the set A such that for all AB belong to A, if AB belong to R and BA pairs belong to R, then A B is called antisymmetrics. If A are not is equal to B, then it is not called antisymmetrics. The relation R on the set is antisymmetric if for all A, for all B, pair AB belong to R and pair BA belong to R implies that A is equal to B. It means that the pair's elements are equal. Then a relation is called antisymmetrics. Let me give example of antisymmetric relation R is equal to that contain pair 1 2 2 2 3 3 on a set A 1 2 3 4. Is R antisymmetric? Yes, it's antisymmetric. The matrix representation of this relation is given to the matrix of any symmetric related has the property that if Mij is equal to 1 with I not equal to, then Mji will be 0, or in other words either Mij element is equal to 0 or Mji is equal element is equal to 0 when I is not equal to 0. In that case the relation will be antisymmetrics. Example, suppose that the relation R on a set is represented by the matrix MR is its reflexive symmetric or antisymmetric solution because R diagonals of this matrix are equal to 1, so it is symmetric, reflexive. Moreover, because M is symmetric, it follows that R is a symmetric. If we take the transport of this matrix, it will be get the same matrix. So if the this matrix is symmetric matrix, so the relation on that based on this matrix also is symmetric. It is also easy to see that R is a not antisymmetrics. Dear student, the last property of relations is transitive relation. Definition: the relation R on a set is called transitive relations if whenever A B pair belong to R and B C pair belong to R, then A C pair belong to R for all A B C belong to A. The relation on set is transitive if we have for all A, for all B, for all C pair AB belong to R and pair BC belong to R imply that pair AC also belong to R. Let we consider transitive relations. Example, relation R AB pairs and A divides P on set A 1 2 3 4. It is a transitive relation. First we get the relations and which pairs are 1 1 1 2 1 3 1 4 2 2 2 4 3 3 and 4 4 relations. First we take first pair in relations, that is 1 1, and we take the second pair, that is 1 2. In first pair A is equal to 1, B is equal to 1, and second pair A is equal to 1 and B is equal to 2. If we consider this value, then we get easily that it is a transitive relation, and we make we get explanation from relations that we can other relations like that. Second example, relations R and A is not equal to on B, and this case is R is a transitive relation, then we get relations 1 and no, it is transitive because 1 2 belong to R, 2 1 belong to R, but 1 1 not belong to R, because if we consider first relations A B and if we reverse relation A B, then it must be 1 1 relation belong to relation R, then it is a transitive, otherwise it is not transitive. Example 3, let relation R 1 2 2 2 3 3 on set is R is transitive. Yes, it is transitive relations. Thank you dear. Hopefully you will get idea about relations overview and relations on sets, matrix relation of relations, and the property of relations that are reflexive, irreflexive, and symmetric, antisymmetric, and transitive. And we also give the transitive relation using metric notations, and using metric notation you can easily identify that a relation is reflexive, irreflexive, antisymmetric, or symmetric. So next the topic we will cover in second lecture is the combination of relations. That is the cover topic of 13 lectures and given introduction lectures. Hopefully our student will be to read the next lecture first, clearly understand first lecture, and also itself do some example, then student easily get the concept of the relations relations on sets and properties of relations. So dear student, Allah Hafiz, and we will meet in next lectures. And our students, I convey a message that the synchronized communications or meeting will be held in this week, every week on Friday 10 a.m. to 11 a.m. for discussion of deliver 2 lectures and each week. Okay, Allah Hafiz.